Now that we have talked about the unit circle and all the different trig functions, now we're going to mush these things together into expressions and eventually solve some equations with them. But first we're going to look at some just real basic ones before we get to the harder ones. So this is 4.3 right triangle trigonometry. This starts out by saying use trig identities to transform the left side of the equation into the right side. Okay? When you're doing these things, you always want to change them to terms of sine and cosine. So I always want these in terms of sine and cosine. That will make your life a whole lot easier when you're doing these problems like this. Okay? Excuse me. So, looking at your formula sheet that you have, your trig identity sheet, if you don't have one of those, it's also on the iTunes U class and the materials for section 4.3. So make sure you have that to follow along. But cosine is just cosine because it's already in terms of cosine. So I'm just going to write cosine of. And then secant, if you look on your sheet, secant is really the reciprocal to cosine. So that is 1 over cosine. And now I'm just going to go ahead and write that over 1, so they're both fractions, and what of course happens to our fractions here, those cancel each other out, so we're left with 1 is equal to 1. Okay, so some of them are this easy, but they do get a little bit more difficult, so let's move on to example number 2. Okay, now we'll move on to example 2. It says cotangent of alpha times sine of alpha is equal to cosine of, that should be an alpha right there as well. So again, we want to do everything in terms of sine and cosine. So sine obviously is going to stay put there. Cotangent, remember cotangent is the reciprocal to tangent. And we know tangent is really sine over cosine. So the reciprocal to that would be, flip that around, be cosine over sine. So we multiply those together. What happens to the sines? They do cancel out indeed. So that we're only left with cosine of alpha equals cosine of alpha. We have the left side and the right side equal to each other. And that's all it is for example number 2. Now example number 3 looks a little more difficult. Okay, but what we do with this is just do, again, we want to get one side is equal to the other. So let's just start. The left side looks more complicated there, so I'm going to start on the left side. We have 1 plus sign and 1 minus sign, so let's just go ahead and do this distributing. 1 times 1 is 1. 1 times the negative sign is a negative sign. 1 times sign is a positive sign, and a negative times a positive is a negative sign squared. Make sure you do put the squared with the sign, not with the angle, the theta or the alpha or the beta or whatever. It always goes with the sine or cosine or whatever it is that you're looking at. Okay, so what happens to these two middle terms? Those guys cancel each other out, so we're left with 1 minus sine squared. And from your formula sheet that you have, if you're looking at that top left corner, the basic ones there that talks about, it says sine squared plus cosine squared is equal to 1. And it also has just below that 1 minus sine squared is equal to cosine squared. So my left side and right side both equal each other, and that's all you have to do. And that solves that problem right there. So moving on to the last page of the notes. These notes are a little bit shorter, quicker than the other ones that we've been doing. It's always a good thing. Complementary angles. Remember, complementary angles are angles that add up to 90 degrees. Okay? So let's look at something else. Let's look at sine of 30 degrees. If you look at your unit circle or your chart or anything that you have, or if you just look at a triangle, you know that sine of 30 degrees is equal to 1/2. Okay? Now what is the complementary to 30 degrees? That would be 60 degrees. And I'm going to look at the cosine of 60 degrees. And it says, and if you click on anything or type it in your calculator or do however you want to do it, you also come up with 1/2. Okay? What do you notice about these guys? These guys are complementary and their values are the exact same. Let's look at another example. Tangent of 45 is 1. Cotangent of 45 degrees That's also equal to 1. Again, these guys are complementary to each other. Exactly the same. Let's go ahead and look at the last one, the last pairs that we have. So secant of 60 degrees. If you look at that on your chart that you filled in, you should see it comes out to be 2. And if you do cosecant of 30 degrees, that is also 2. So again, complementary to each other, exact same values. Okay? So we're going to use these examples to help us understand what is going on this page right here. The complementary angles. Okay? Sine and cosine match up with each other. The sine of one angle and the cosine of its complement, they're exactly the same, just like what we said right here. If the angles are complementary, the values of those are exactly the same. Okay? And it works that way for all 3 pairs of those. Sine, cosine, tangent, cotangent, secant, cosecant. Okay? And that is all that this page or this chart is showing right here. That's all this chart is showing, is how they match up with each other. Okay? So, let's look at the example they have. Use the given values and the trig identities to find the indicated trig functions. So, tangent of beta is equal to 5. I'm going to go ahead and make that into a fraction, let's say 5 over 1, just so I get used to having all these things in terms of fractions. Okay? And one thing that I always do with every single problem I do with trig that has to do with something like this, I always draw the triangle out. Okay? And I always put it in quadrant number 1 because we know everything's positive there unless it's a negative value. Tangent is opposite over adjacent. Yes, opposite over adjacent. So that was going to be, if this is my angle here, if this is beta over here, opposite is 5, adjacent is 1. Okay? We know this is our right angle. So can you use Pythagorean theorem to figure out your hypotenuse? You should be able to do that at this point, and come it to be square root of 26. Okay? So that's going to help us solve some of these. Now let's look at the first one, cotangent of beta. How is cotangent and tangent related to each other? And if you look on your chart, or if you have memorized it already, which is good, you would have, we know those are reciprocals of each other. So if tangent is 5 over 1, cotangent is going to be 1 over 5. That's all you have to do for that one. Okay? I'm going to go ahead and jump down here to the tangent of 90 minus beta, because these kind of do go hand in hand. Because remember, the tangent and the cotangent, if they're complementary to each other, then they're equal to each other. So what's happening is, if I take the cotangent of beta as 1/5, the tangent of 90 minus that angle is also going to be the exact same value, because that's how they matched up with each other. So if this was cotangent of 30, that would be tangent of 60. Those are complementary to each other, so they're the exact same value. Okay. Excuse me there. Cosine of beta. Let's just look at our triangle here to get the cosine value. So cosine is adjacent over hypotenuse. That would be 1 over square root of 26. Now can we have a square root in the denominator? No, we cannot. So that's got to be we have to rationalize the denominator. So by multiplying it to both the numerator and denominator, we get square root of 26 over 26. Okay? And a lot of people want to try to reduce those out, but you can't. Please don't do that, because one's underneath the square root, one's not. Okay? And that takes care of that one. And going down to cosecant of beta. Cosecant is the reciprocal to, which one is it? It would be sine, cosine, sine. The reciprocal of sine would be hypotenuse over opposite, because sine is opposite over hypotenuse, so the reciprocal would be hypotenuse over opposite. So if I just basically look at the triangle up here, hypotenuse, square root of 26, opposite is 5. And there's your answer. Okay? So, short, quick lesson today. Hopefully you've understood it all. If not, make sure you write down those questions to ask your teacher in class tomorrow.